The second solution is, we just talked about this, so I'm just skipping this. The second solution is stalling and bypassing. So we'll see this. The first instruction allowed inside the pipeline. But before that, you just remember that we have used the interstage buffers on every stage. Okay, the green bars which we have addressed in the previous lectures, okay, they are the interstage buffers, temporary memory. Okay, so assume that here the first instruction enters into the pipeline at the first cycle. At the second cycle, instruction 1 move into the instruction decode stage. Instruction 2 enters into the instruction fetching stage. At the third cycle, instruction 1 enters into execution stage. So the ALU, the arithmetic and logic unit in the pipeline, that takes the input 1 is R2, input 2 is R1, and the result of this ALU is R2 plus R1. That result is temporarily stored into the interstage buffer. So this value is ready here. Okay, so this value is ready. So that is ready in the interstage buffer, which is supposed to write in R3 in the write back stage in the fifth cycle. Correct? The result will be write back into R3 at the fifth stage, first half. But the ALU output is ready in the interstage buffer here. R2 plus R1 value is ready. So then at the third stage, instruction 2 enters into instruction decode stage. Instruction 1 allowed inside the pipe in the instruction fetching stage. At the fourth cycle, instruction 1 moves into the memory access stage, and instruction 2 enters into the execution stage. But what is the input for the instruction 2 execution stage? Means the input 1 is R2 plus R1, which is available in the interstage buffer in the previous stage, and input 2 is R5. So that is supplied. Actually, input 1 for second register is R3, but R3 value is in the interstage buffer, it is available. So that value is forwarding here. Okay, directly. This value is forwarding by bypassing stage 4 and stage 5. So that is the advantage of interstage buffer, which we discussed during the data path design of multi-cycle. Right? So here at the fourth stage, instruction 3 enters into instruction decode stage, and instruction 4 enters into instruction fetching stage. Now see, at the fifth cycle, the R2 plus R1 writes into R3 register in the first half cycle, and instruction 2 enters into the memory access stage because this intermediate value is already taken for calculation. So instruction 3 will enter into execution stage by reading the interstage buffer value here. I'm just showing this related to this part. So this R2 plus R1 will be supplied, okay, from here for execution. So that enters into the execution stage. Instruction 4 enters into instruction decode stage and continues their execution smoothly. So then these 4 instructions completes their execution in 8 cycles only. So the average cycles per instruction is computed as total taken cycles are 8 or 4 instruction, that is 2 cycles per instruction. So this is called bypass and forwarding, bypassing 2 stages, 2 cycles, and forwarding this result to the instruction 2 and instruction 3 for their execution. So for that, bypass and forwarding, the interstage buffer is used to improve the performance of a processor by reducing the execution time. In the previous one, if it is stalled, it takes 10 cycles. If introducing a interstage buffer, it took only 8 cycles. So this is the second solution of read after write hazard.